Hello everyone. My name is Aashish Dhakal, and today I'll be discussing efficient cloud implementation for Moodle in context of the distance learning. So let's move to the introduction part. Distance education has become a rapidly growing necessity, especially after the pandemic, with millions of students worldwide turning into online education. Learning management systems, LMS like Moodle have become very important. Moodle is many of you may know is a highly customizable open source LMS. Our goal today is to explore the most efficient and cost effective way to implement Moodle on cloud infrastructure, ensuring that we balance performance with affordability. So to guide our exploration, we focus on several key research questions. So what is the optimal cloud setup for Moodle that balances performance and the cost? How much memory is required per concurrent user in a private cloud environment? And how can we use elastic infrastructure like auto scaling to maintain cost efficiency? What are the best resource allocation strategies for cloud providers? Maybe if you are using AWS, the EC2 instances. How does instance scaling impact the resilience and availability of the system? So these questions will form the foundation of our discussion today. So now, why cloud hosting for Moodle? The primary reason is scalability. Distance learning demands global accessibility, and cloud infrastructure can scale efficiently to handle this. We have major cloud providers like AWS, Azure, Google Cloud Platform. While they offer robust services, we must address challenges like performance, security, and scalability also. So the need for cloud comes from Moodle's global user base, meaning we need to serve students from different parts of the world simultaneously without performance bottlenecks or security issues. So this discussion will basically be with a kind of experimental. So for the experimental setup, our setup revolves around AWS, where we use EC2 instances to benchmark Moodle's performance. We employed low-cost, Python-based load testing tool to simulate concurrent users on Moodle, and AWS CloudWatch to monitor CPU utilization and track our scaling metrics. This setup allowed us to test different cloud configurations and their impact on both performance and cost. So let's move to the experiments. For the first experiment, we tested Moodle with 100 concurrent users on a T3.large instance, which has 2 CPU cores and 8 GB of RAM. At peak usage, the CPU utilization reached 17%, which is well below the critical threshold. The cost for the setup was approximately around $100, including auto scaling. This experiment served as a baseline to understand how Moodle performs with a small number of users. So moving to the second experiment, we scaled up to 1,000 concurrent users using the same instance. At peak load, we used 7 instances with CPU utilization at 45%. That's average. The cost for the setup was approximately 300 USD. So this experiment showed us that while the system could handle a larger user base, the cost was significantly higher than for 100 users, and we needed more efficient configuration. So we moved to the third experiment. Here we reduced the resource of instances a bit. So we used T3.medium instances, and which has 2 CPU cores and 4 GB of RAM. 4 GB of RAM. So that was obvious. It used more number of instances than it used before. It used 11 instances, and the CPU utilization was at 18%. But importantly, we reduced the cost to $250, which was more efficient than the T3.large setup. This experiment highlighted the cost saving we can achieve by fine-tuning our cloud configuration, especially when managing larger user bases. So basically, this is just a visualization of the same experience, experiment 1, experiment 2, and experiment 3. We ended the experiment with third experiment. So we are considering the third one is the optimized setup for now. So after that, we are calculating now the user to memory ratio, basically what resource we need for the provided number of concurrent users. they will be accessing who will be accessing the Moodle. So l- first experiment one had 6.25 concurrent users per GB. So the GB is the memory RAM. So, and the second managed around 17.85 concurrent users per GB. And the third one had higher efficiency than the first two, which had around 22.72 concurrent users per GB. So this was T3 dot medium. Again, this was T3 dot medium instances are more cost effective for handling large number of users while maintaining performance. So what are the recommendation after these experiments? So based on these experiments, we offer the following recommendation for efficient model cloud implementation. The first one is elastic infrastructure. So we'll be utilizing auto scaling based on CPU load to ensure that Moodle can handle fluctuating user demand without unnecessary costs. So again, next one is memory allocation. From the calculation we did for user to memory ratio, we'll be allocating approximately 1 GB of memory for every expected 25 concurrent users to ensure smooth performance and availability zones. So we'll be utilizing multiple availability zones to improve systems resilience and minimize downtime. So these strategies will ensure that model can deliver an excellent user experience at a manageable cost. So how the future work, how can we make this even better? So the first one can be cache implementation. By improving caching, we can reduce redundant requests and improve systems responsiveness. The next one, database optimization. We will look into database connection, pooling, and persistence connections to minimize database-related bottlenecks, and maybe a faster storage. The experiments were conducted on Amazon EBS volumes. Maybe we can investigate with NVMe volumes, which offer faster data access speeds compared to traditional storage like the one we used, Amazon EBS. So these optimization will help us improve Moodle's overall performance, especially as user demand increases. So to summarize our experiments, so that finding the right cloud configuration is key uh, to balancing performance and cost when implementing Moodle in a distance learning setup. For now, we recommend T3 dot medium instances for handling up to 1,000 concurrent users. Is they offer better cost efficiency, but in future, additional research on caching, database optimization, and faster storage options could lead to even better performance at a lower cost. With the same, we aim to ensure that Moodle remains a viable, scalable option for educational institutions around the world. So these are the references. Thank you for your time. I'm happy to answer any questions if you have about the discussion.
Thank you so much. Thank you so much for your great presentation, Ashish. So time right now is for audience, for our participants. If you have any questions, please unmute yourself or just drop it in the chat box. We actually have a question, I think, and that's for you, Ashish. Someone, Manu, I think. Please correct me if I'm pronouncing your name incorrectly. He asked, I would like to conclude being a certified cloud architect for major cloud providers. Please let me know if I can get a chance.
Yeah, sure. I think he wants to conclude maybe share some point. Yeah.
Yeah, I would like to conclude this one. Sorry, Ashish, I would like to know, like, moving forward first, if you move with, let's say, uh, more than a million users, what like enhancements or upgrades are you planning on the instances side?
Okay. So I have not considered the million users yet because the experiments I did was the concurrent one. So, it's primarily a small level school or university with maybe 10,000s of users may experience 1,000 concurrent users during exam times or quiz times or something like that. So I concluded the experiment till that. So I have not thought about a million of users as of now.
Okay, because I was thinking in that terms, let's say, even for Westcliff University, if you want to
Yeah,
bring on, um, all the students and the educators and just sign up them, and
yeah.
if they use concurrently, those instances will have to, be able to handle that workload or, the
Yeah,
request or
yeah, it's a auto scaling group. So the instances will basically keep on increasing, but maybe
the cost will
managing,
also increase.
yeah,
Yeah.
the cost will also increase. So maybe managing the critical workload with the regular instances and the some non-critical workload, separating them into spot instances might, yeah, decrease the cost.
Yeah, yeah, that was my whole point. We can
Yeah,
always use on-spot instances
yeah, right.
whenever there is always I mean, there is a chance of,
Yeah,
peak
so
hours.
the cost will be maybe one third of the regular instances.
Yeah, yeah, sounds good. Thank you. That's pretty much it, and it was a good presentation. Thank you for sharing your insights.
Thank you.
Ashish, this is Tom Santamaria, actually the director for instructional technologies, and near and dear to my heart, Moodle and architecture is definitely my baby, and obviously Westcliff is looking at some of those newer technologies, and you hit it right on the head with the Elasticache and Manu, what he's kind of talking about. Well, we're scheduling, or what we've got part of the architecture is that EC2 with auto scaling. So what's really
Yeah,
cool about it, it can scale up or scale down depending on the need and depending on the traffic. Coupled with ELB, elastic load balancing, you believe it or not, you can really stretch that architecture pretty much as far as you need to. So what's really cool about that new architecture is that with the new Amazon Web Services architectures, you can combine them and really create a very robust architecture that's responsive, but also able to stretch and flex when the growth occurs and is needed. So we're
I I
actually,
tot- I
yeah.
totally agree with that one. I was just thinking about, cost and operational cost, keeping
Well,
that into consideration, like for the peak hours, the operational cost.
what's cool
So
about
that
it
was,
is the way
the,
the framework is set up. We pay for what we use.
yeah, I
We're
understand.
not we're not set at a certain range. We based on whatever service we use. If we flex up, we flex down, and we peak during peak hours, Sunday night when assignments are due, obviously.
yeah.
Yeah, some of the Amazon Web Services, and Ashish, I really do appreciate this presentation. Very well done. But you're right in my head in what we're doing with our new AWS architecture for Moodle. What we're doing with Moodle and our LMS, and really almost any LMS could adapt to this new architecture. So,
Right, right. Yeah, thanks.
no, good job.
Thank you.
We have 2 more minutes, everyone. If you have any questions, please feel free to unmute yourself or drop it in the chat. Thank you.
Actually, what I'm going to do here for Manu and Ashish, I'm going to put my email in here if you want to chat more about this. It's Thomas Santamaria. I mean, you guys probably may or may not know me, but at westcliff.edu. And that's my primary role currently is LMS administration and obviously architecture and making sure you guys have access to your classes and to the platform when you need to, and it can handle any load that we throw at it. So if you're
Yeah.
interested, you can email me questions or maybe support or assistance. We are looking at maybe starting a couple internship stuff. So just let me know, shoot me an email.
Okay. Yeah. I'll be in touch with you.
Yep. Thank you,
Thank you for
Mary.
it.
Thank you, Professor Tischler. Appreciate that. And Thomas, do another.
Oh, absolutely. You've helped me and many a students many a times of the day. So thank you.
Okay, thank you so much, Aashish, for your great presentation. Thank you so much, everyone, for listening and paying attention. We're closing out this session, and the next presentation starts at 8:15 or 8:17. Yeah, thank you.